Did you know that our Earth's crust is not one solid piece but a jigsaw puzzle of massive slabs known as tectonic plates? These pieces are always on the move, and where they meet are what we call plate boundaries. Now, imagine the Earth as a boiling pot of soup. The heat from the burner, much like the Earth's core, causes the soup, or the Earth's mantle, to circulate in a process called convection. It's this convection that causes the tectonic plates to move around on the Earth's surface. These tectonic plates are like giant rafts floating on the semi-fluid mantle below. They're constantly jostling for space, moving away from each other, colliding or sliding past each other. And it's exactly at these points of contact, these plate boundaries, where the magic of geology really happens. But what makes these plates move? Imagine a pot of caramel on a stove. The heat from the stove melts the sugar, turning it into liquid caramel. The Earth's core functions similarly, generating heat from radioactive decay, which then creates the molten rock, or magma, in the Earth's mantle. This magma circulates, pushing and pulling the tectonic plates above like rafts on a restless sea. Now let's talk a bit about these plate boundaries. There are three main types: divergent, convergent, and transform. Each type has its own unique set of characteristics and can cause different geological events like earthquakes, volcanic eruptions, and the creation of mountain ranges, among other things. To understand our world better, it's crucial to understand these plate boundaries. They're the hidden, underground architects of our planet's geography, continually shaping and reshaping the continents and ocean floors. Now that we've set the stage, it's time to delve deeper into the three main types of plate boundaries: divergent, convergent, and transform. So buckle up for an incredible journey to the center of the Earth. It's going to be a ride full of fascinating discoveries and breathtaking phenomena. Stay tuned. Imagine two giants pulling a blanket from either end. This is what happens at a divergent boundary. In the grand scheme of Earth's geological processes, divergent boundaries play a fascinating role. They are like the stage managers of the Earth's crust, directing a never-ending performance of creation and transformation. But what exactly are they? Divergent boundaries are places on our planet where two tectonic plates are moving apart. Picture two massive slabs of rock, each the size of continents, slowly drifting away from each other. It's a process that unfolds over millions of years, and it's happening right beneath our feet. As these tectonic plates separate, they create a gap. But this isn't just any gap. It's a gateway to the fiery depths of the Earth's mantle. This gap allows magma, molten rock from deep within the Earth, to rise to the surface. Now, you might be wondering, what happens when this magma reaches the surface? Well, it cools down and solidifies, forming new crust. That's right. New crust is born at divergent boundaries, and it's a process that's been shaping our planet for billions of years. From the bottom of the Atlantic Ocean, where the mid-Atlantic ridge is slowly pushing North America and Europe apart, to the East African Rift Valley, where a new ocean is in the making, divergent boundaries are constantly reshaping our world. But it's not all about creating new land. The process also recycles old crust back into the mantle. In essence, divergent boundaries are Earth's own recycling system, taking old crust and replacing it with new. This incredible process is part of what makes our planet so dynamic and ever-changing. It's a testament to the Earth's capacity for renewal and transformation. So, divergent boundaries are essentially Earth's natural construction zones, building new crust every day. They are the architects of our planet's future, designing and redesigning the face of the Earth with each passing eon, a silent symphony of creation and destruction, all happening beneath our feet. So, the next time you look at a map, remember, it's not just a picture. It's a snapshot of our ever-evolving world. So, divergent boundaries are essentially Earth's natural construction zones, building new crust every day. Now picture those same two giants pushing towards each other, with a boulder in between. This is a convergent boundary. Imagine two colossal titans, the tectonic plates, locked in an eternal struggle. They slide towards each other, their edges grinding and clashing. This is the world of convergent boundaries, a place of intense pressure and dramatic geological activity. At these boundaries, the crust isn't being created or destroyed evenly. It's a brutal, relentless battle of wills. One plate, typically the denser of the two, is forced down into the mantle beneath the other. This process, known as subduction, can lead to some of the most spectacular and devastating phenomena on Earth. Think of the mighty Himalayas or the majestic Andes. These towering mountain ranges didn't just spring up out of nowhere. They're the result of millions of years of tectonic plates colliding and pushing upwards. It's like crumpling a piece of paper. The surface buckles and folds under the immense pressure, creating these towering peaks. But it's not just mountains that form at convergent boundaries. The subduction of oceanic plates can lead to the formation of deep-sea trenches, the deepest parts of our oceans. These trenches, like the Mariana Trench in the Western Pacific, are a testament to the incredible forces at play beneath our feet. And then there are the volcanoes. As the subducting plate is forced deeper into the earth, it starts to melt due to the intense heat and pressure. This molten rock, or magma, rises through the crust and can erupt as a volcano. This is why we see so many volcanoes in regions where plates are converging, like the infamous Ring of Fire around the Pacific Ocean. So, convergent boundaries are not just about destruction, they're also about creation, about the constant reshaping of our planet's surface. They're a testament to the incredible power of our Earth, a power that can both create and destroy. Convergent boundaries, then, are the Earth's demolition sites, tearing down and reshaping the crust in dramatic ways. Ever tried to slide two heavy objects past each other? That's a transform boundary for you. Welcome to the world of transform boundaries, where two tectonic plates slide horizontally past each other. It's like a game of tug-of-war. But instead of a rope, we've got gigantic chunks of the Earth's crust. And instead of two teams, we have two tectonic plates, each with a will of its own. Now, picture this, two stiff and stubborn plates, each thousands of miles across, grinding past one another. It's not exactly a smooth dance. The pressure builds as they scrape and jostle, locked in their eternal tussle. And when that pressure gets too much, well, it has to go somewhere. The result? An earthquake. This is the reality of life along the San Andreas Fault in California. This fault line is a prime example of a transform boundary, where the Pacific Plate and the North American Plate are in constant motion against each other. The plates aren't just sliding past each other on a flat surface, though. They're moving on a curve, with the Pacific Plate moving northwest and the North American Plate moving southeast. The tension that builds up between these two plates is immense. When it's released, the energy travels through the Earth, causing the ground to shake and tremble. This is what we call an earthquake, and in places like California, where millions of people live right on top of this boundary, the impacts can be devastating. But it's not all doom and gloom. Understanding these boundaries and the earthquakes they cause is crucial for our survival. Scientists study the movement of these plates, predicting when and where the next big quake might occur. This knowledge allows us to build safer structures, develop effective evacuation plans, and ultimately save lives. So, while transform boundaries might seem like the Earth's troublemakers, they're also key to understanding our dynamic planet. They remind us of the incredible power beneath our feet and the importance of respecting and understanding our Earth. Transform boundaries, then, are the Earth's friction points, causing ground-shaking consequences when the plates get stuck. So, we've journeyed through the fascinating world of plate boundaries. But what does this mean for us? We've seen the birth of new crust at divergent boundaries, where tectonic plates drift apart and molten rock rises from the mantle to create new oceanic crust. This process, called seafloor spreading, has shaped our oceans and continents over billions of years. Then we've witnessed the massive clash at convergent boundaries, where plates collide. This can form mountain ranges like the Himalayas when continental plates crash, and deep-sea trenches and volcanic arcs when one oceanic plate dives under another in a process called subduction. And let's not forget transform boundaries, where plates slide past each other. These are the culprits behind many of Earth's earthquakes, like the ones along the infamous San Andreas Fault in California. Now, why is all of this important? Well, understanding plate tectonics is key to predicting natural disasters. The more we know about how and why the Earth's crust moves, the better we can prepare for earthquakes, volcanic eruptions, and tsunamis. But it's not just about bracing for disasters. Plate tectonics also helps us study Earth's past. By looking at the movement and arrangement of continents, we can understand how our planet has evolved over billions of years. And it's not just about the past, either. Understanding plate tectonics can also help us anticipate future geographical changes. For instance, scientists predict that the African and Eurasian plates will eventually close the Mediterranean Sea, creating a new mountain range in its place. So as we wrap up our journey through the world of plate boundaries, remember this. Our understanding of these phenomena is crucial to understanding our planet's past, present, and future. Remember, Our Earth is a dynamic and ever-changing planet, and it's the movement of these tectonic plates that truly shapes our world. Until next time, keep exploring.